Homework U11b Question 1 Part A. We've been asked to express 5x plus 3 over 2x minus 3x plus 2 in partial fractions. So I've set this up here with one variable a over my first factor and b over my second factor. We don't have any repeated roots, so I don't have to worry about getting extra fractions here. I should also be checking whether this is a top-heavy fraction, which is where the highest power on the numerator is either equal to or greater than the highest power on the denominator were we to expand. I've got a linear term over a quadratic term, so this is not top-heavy. I don't need to do any division first. What I do need to do to solve this is to multiply both sides by 2x minus 3 and x plus 2. This has the effect of getting rid of both brackets on the bottom and both on the top, but with appropriate multiplication. It'll leave me with 5x plus 3 is equal to a lots of x plus 2 plus b lots of 2x minus 3. Now I can expand the brackets and compare like terms, x terms to x terms, constant terms to constant terms, but it's usually easier to plug in particular values of x and eliminate a variable. If I were to plug in x equals negative 2, that is going to give me minus 7 on the left hand side. My first bracket is going to be equal to 0 and it's going to disappear, and I'm just going to be left with minus 4 take away 3 lots of b, which is minus 7b. Therefore b is equal to 1. I can do the same again with the x term that I'd need to eliminate the second bracket. That one is going to be 3 over 2. If I plug that into my left hand side, I get 21 over 2. If I plug that into my right hand side, I get 7 over 2 lots of a. So this gives me a is equal to 3. Now I've not been asked to find a and b, I've been asked to express my fraction in partial fractions. So I do need to make sure that I finish off by writing 5x plus 3 over 2x minus 3 lots of x plus 2 is equal to 3 over 2x minus 3 plus 1 over x plus 2. In part B, we're asked to find the exact value of the integral between the limits of 6 over 2, giving our answer as a single logarithm. Now it does say hence, which means we do have to use our answer to part A. It doesn't say hence or otherwise, so we don't have any options. Now because it's a part B, I know that we do need to do partial fractions, splitting it up. If I hadn't had that as a clue, I'd be looking at this initial integral and I've clearly got a fraction to deal with. That should be my first clue that this is going to have to be done with partial fractions. The denominator needs to be factorizable, which it is, it's already been done, and I'd be looking to see whether I have a top-heavy fraction, which, as discussed in part A, I do not. Now, there's a couple of different approaches we can do to deal with these logs. Anytime we are integrating 1 over a linear term, we're going to get some constant times the natural log of the linear term. We can do the reverse chain rule to divide by the coefficient of x in this case, or we could rewrite this as a standard pattern, which is my preferred method for this type of problem. The standard pattern is when we have the differential of the denominator as our numerator. This second fraction fits that format because the differential of x plus 2 is 1. This one doesn't quite have that format. It's got it very similar, it's just a constant multiplier of it, but the differential of 2x minus 3 is 2, not 3. What I can do is I can take the 3 outside of my integral, I can put a 2 on the top of my integral, and then I can divide by 2. And now if I multiply that, I'm going to get back to what I originally had, but I now have the differential of 2x minus 3 as the numerator of my fraction before I integrate it. This means I can just go straight to writing 3 over 2 times the natural log of 2x minus 3. I don't have to worry about using the reverse chain rule in this case. So this gives me 3 over 2 log 2x minus 3. This one already fitted that format, so I just get natural log x plus 2. Because I was integrating between limits, I don't need a constant of integration here. Now the calculator probably will do this in one go, but we can get there doing it manually in case your calculator's not been set up right or it doesn't have natural display. If I plug in x equals 6, I get 3 over 2 log 9 plus log 8, and then I will take away 3 3 over 2 lots of log 1, take away log 4. That takeaway has come because it's minus the entire bracket, and I've essentially expanded the bracket. Natural log 1 is 0, so that term is just going to disappear. The constant on the outside can be brought up to the top using the power law. That gives me natural log of 9 to the power of 3 over 2 plus log 8 minus log 4. Log 9 can be, log 9 to the power of 3 over 2. The over 2 part is a square root, the 3 is a cube, square root of 9 is 3, 3 cubed is 27. So I have log 27 plus log 8 minus log 4. Using log laws, 2 logs added together get multiplied. Taking away a log, you divide by that term on the inside. 8 over 4 is 2, so my final answer is log 54.